All right, what we're going to do now is we're going to look at a different coordinate system than what we're used to, the XY plane, or what's also known as a Cartesian plane or a rectangular coordinate system. What we're actually going to look at now is called the polar coordinate system. And what I have right here is I actually have a polar graph. It's much like the XY plane where you're going to have two different axes. We have an axis here and an axis here, except those axes are going to intersect the radius of concentric circles. So right here we have my first circle, my second circle, my third circle. So this would be 1, 2, 3, a radius of 1, radius of 2, radius of 3. The center of the coordinate system right here, we're not going to call that the origin anymore because that's for the XY plane or the rectangular plane. We're actually going to call it the pole. So right here is what's called the pole, which is a 0 radius. Now if you notice, there's also these other lines coming out. So these lines actually represent angles, like how much did I rotate? So in this case, because there's only, let's see, we've got 0, this is going to be 30, 60, and then 90 is up in here. So these are going to represent rotation. So these are going to be my radiuses. The concentric circles will tell me my radiuses. And then these lines, as they're coming out, are actually telling me the angle. Now the way that we're going to plot points on this, well, we got to know a new way that we can actually write a point. So one way that we're going to be able to write a point, well, the way we're going to write a point is going to be r comma theta. I'm going to give you the radius, and I'm going to give you the angle. So r comma theta is how we're actually going to plot this out. Now, say I want to plot out a point, and let me pop a point on here. So I now have a point right here. And this point, the way we're going to figure out what the actual coordinate of this is we're going to start at the pole. We're going to count how many radiuses, 1, 2, and then we're going to rotate to the angle right here, which is going to be, this one is at pi over 3. So this point is going to be 2 comma pi over 3. A radius of 2 is rotated an angle at pi over 3. This is where our angles of standard position from trigonometry is really going to be helpful, and knowing the unit circle is going to be extremely helpful on this. Now, there's other ways that we can actually write this point. All right, there's another way we can actually write this point. So we have the point and at 2 pi over 3. On our polar coordinate system, these points aren't distinct like on the rectangular system. Like there's only one point at 1, 1. There's actually an infinite amount of ways that I can represent this point 2 pi over 3. What I can do is I can actually go, let's say, another pi or 180 degrees. But this is going to allow me to do a negative radius, because this here is my positive radius coming from the pole out to a point. But if I come from an angle and I go past through the pole and up to the point, that would be a negative radius. So I can actually write this as negative 2, comma, and then now I'm in quadrant 3 basically for my angles. So this would be 4 pi over 3. Now there are nice little formulas that's going to allow us to kind of figure out how we can write infinite amount of points, because there's really many different ways we can do this. We can even do a negative angle with this. It doesn't matter. What matters is if they're on the same line. The pole is going to decide if you have a positive or negative radius. So if I have a point up over in here, but my angle's over here, I have to go through the pole, which is going to make a negative radius. So we can do a formula of your radius, or radius, and then your angle is going to be your angle plus 2 pi k, and of course k is an element of your integers. Or if you have a negative radius, you're going to be able to do your angle plus pi plus 2 pi k. And of course k is an integer, positive 1, positive 2, negative 1, negative 2, yada yada yada. These are just formulas that could give you every different type of polar coordinate and a polar point. So if I give you 1 or if I give you a point, you should be able to give me 2, 3, 4 different ones. Hi, I'm Mr. Buzzer, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe as well as the bell for notifications to receive future videos on high school mathematics.